Hello children, how are you all? Hope you all are fine. Okay, I have seen your homeworks. Very good. You are studying well. Okay, write down your assignment daily. Okay children, the assignment which we are giving you, write it. Okay, right. In the previous class, we have seen the derivations, okay, equations of motions. Have you written? Have you understand it clearly? Okay, that is a very important question. Okay, you have to study about all the derivations. Okay, right. Now we are going to see about the rest of features such as distance, displacement, differential calculus, integral calculus, okay, like that. Okay, we are going to see about that in kinematics unit 2. Okay children, take your book page number 60. Okay. Now, what is distance and displacement? Have you heard about it? What is distance and displacement? Okay, distance is a scalar quantity. Okay, distance is a scalar quantity, whereas displacement is a vector quantity. Okay, distance is a scalar, whereas displacement is a vector. Okay, vector means it determines both magnitude and direction. Okay, but scalar means only what? Magnitude. Okay, now what is distance? Distance na enna? It is the actual path travelled by an object in a given interval of time. Okay, there is a motion. Okay, there is a motion. In a motion, distance is the actual path travelled by an object in a given interval of time. Distance is the actual path travelled by an object in a given interval of time. Actual path travelled by a object. See the picture, there is a point A and B. Okay, from A is the initial point, B is the final point. Okay, from A a person is traveling to B. He can go straight, but there is another route. Okay, he is going through that route. Okay, so the length of the path he is traveling, okay, that is called distance. Okay, the shortest distance, no, A and B, we can go in a short way also. That short distance is called displacement. So, displacement is the difference between final and initial position of the object. Do you understand? Displacement is the difference between final and initial position of the object with respect to time. Okay, it can also be defined as the shortest distance. Shortest distance between two positions of the object, and its direction is from final position, okay, from initial to final position during a given interval of time. Okay children, have you understood? Distance na enna, displacement na ennangradhu theliva purinjudha? Okay, the starting point and ending point, if you subtract the distance, the shortest distance between A and B is called displacement. Okay, and the longest length travelled, okay, that is called distance. Okay, I will explain you clearly. Further, I am going to explain you clearly, okay, by an illustration. Okay children, what is distance and what is displacement? Okay, see the picture. A man moves from a point A. See, there is a man, isn't it? Okay, a man with a stick. Okay, that man moves from a point A to the point B. Okay, from A to point B, then going to point C, and then going to point D. Okay, A to B, B to C, C to D. That man is moving. Now you are asked to find the distance and displacement travelled. You are asked to find the distance and displacement. Okay. Okay, in this chapter, each and every topic there are many problems. Okay, first topic is distance and displacement. In distance and displacement, there is also two problems in your book. See example 2.15, example 2.16. Okay, you have to do it as a regular work. In each and every topic I am teaching, you have to do the problems in it. Okay, I will teach you the concept and the formulae, and you have to substitute and write the problems in your note. Okay, side by side you do it. Okay, problems are also asked, okay, will be asked in your exams. Okay children, okay, see here, now we are going to what? We are going to add the distance. What is the distance? Okay, 50 plus 30 plus 50. Okay, CD is at the same distance as AB, no? So we have put 50. Man is traveling from A to D. So the distance he traveled is added, that is called 130 meter. What is displacement? See, what is displacement? From A to D. Okay, we have to find A to B. Appadidane. Distance na the whole distance. Displacement na the shortest distance. Okay. Do you understood clearly? Distance means A to B, B to C, C to D. The whole length you add பண்றது distance. The shortest distance between A and D மட்டும் சொல்றது தான் என்னது displacement. So, the shortest distance is A and D. No, initial and final. So, initial minus final. So, what happens? Initial minus final. See, CB. Okay, that CB value is 30 meter. So, hence the AD value is also 30 meter. Okay, children? And in distance நம்ம magnitude மட்டும் சொல்லுவோம், isn't it? Because அது வந்து scalar quantity. Okay, scalar quantity வந்து magnitude na அந்த வேல்யூவை மட்டும் சொல்லுது. But displacement என்ன சொல்லும்? It is a vector quantity. So it tells about what? Direction and magnitude. 30 meter. Okay, AD ஓட distance என்ன? 30 meter. Okay, he is telling that 30 meter is the magnitude and it is north. Okay, A to D. So it also shows the direction. So displacement is a vector quantity and it shows us the direction. Okay, children, have you understood clearly what is distance and displacement? Okay, you do the sums also. See, in your book there is a first one. It is same like this example. Okay, see the second one I will explain you. An athlete. Okay, an athlete covers 3 rounds on a circular track of radius 50 meter. Okay, in our school also there is a circular track. Okay, anybody run here? Okay, anyone has run during sports. Okay, right. So that in a circular track, okay, the radius is 50 meters. See the picture, the radius. What is the radius? From the center to the end point, that is the radius. So radius is given 50 meter. See the book, page number 60 and example 2.16. Okay, now we have to find the distance and displacement. Okay, now the distance is 3 times he is rounding the ground. Okay, so 3 into 2 pi r, because 2 pi r is the what? For a circle, no? For a circumference, the circumference of a circle is 2 pi r. Okay, so 2 pi r, 3 into 2 pi into r, r value is 50 meter. So the answer is 300 pi meter. Okay, the pi value is 3.14. So we can apply it or we can leave it, no problem. Okay, now here the athlete is starting from a one point, finally he ends at that point, isn't it? Okay, he is running from a point A, at last he reaches the point A only. Do you understood? But in this example the man is starting at the point A and reaching at the point D. So the destination is different, isn't it? So the initial and final points are different in this example, but in this example in a book the initial point is same. So starting from the point A and ending at the point also A. So the displacement will be 0. Displacement will be 0 because the starting and ending points are same. Okay, children, have you understood? Right. Very good. Now, okay, what is displacement vector in Cartesian coordinate system? Displacement vector in Cartesian coordinate system. Okay, Cartesian coordinate system in x, y, z axis. Okay, so in the terms of position vector, okay, let us consider a particle. Okay, moving from a point P1. See the point P1, x, y ங்கிற axisல P1 அப்படிங்கிற ஒரு vector, P2 னு ஒரு vector. Okay, the distance from origin to P1 is R1 and from origin to P2 is R2 vectors. Okay, so now we have to find the resultant. Okay, that red arrow, there is a red arrow, no? That is the resultant vector, that is del R. So R2 minus R1 will be the answer. R2 minus R1 will be the answer for the resultant vector. So R1 is a position vector. Okay, so that is xi plus yj plus zk. Okay, these are the position vectors for R1 vector and R2 vectors, because I think you will study it in maths, okay. You will study the vectors and everything in maths, okay. This will be a new one, but here in physics only the concept is needed, but in mathematical it is very easy if you apply it in sums, okay. You have to study in maths only more, okay, but here you have to know the concept and formula, okay. You have to know the concept and formulas, okay. The final formula, del r equal to r2 minus r1, that is the displacement of a Cartesian coordinate system, okay. So here then r2 vector minus r1 vector, what happens? X2 minus xi, okay. We are taking the two position vectors, no, r1 vector and r2 vector, okay. You apply the r1 and r2 minus, okay. I take I as a common, j as a common, k as a common, you will get a formula, okay. This formula you have to apply in the sums and derive the problems, okay. Example 2.17 also, okay. You apply it and find the answers for that problems. Now, what are differential equations, okay? What are differential equations, okay? The calculus, okay, it is a science of rate of change. It was invented by Newton, okay? There are many types of systems which can be modeled by writing an equation of rate of change phenomena, okay. If here the time is denoted as dt, that is rate of change of time, rate of change of length, rate of change of distance. So the physical quantity, okay, so any physical quantity is represented, okay. In unit 1 itself you all have written the physical quantities, that is force, length, distance, displacement, temperature, okay. So the physical quantities is represented in a form of mathematical function, okay. Physical quantity is represented by a function, okay. Physical quantity is represented by a function in mathematics. So take the example of temperature T. So we know that the temperature of the surroundings is changing throughout the day. Temperature of a surrounding is changing throughout the day. So it increases till noon and decreases in the evening, isn't it? The temperature in surrounding is changing, no? Morning our temperature, night another temperature, afternoon there is another temperature. So there is a change in the temperature. So the rate of change, for denoting the rate of change, for calculating the rate of change, okay, at any time t, the temperature has a unique value. So for representing the temperature, we are using a mathematical variation, mathematical notation. So that is called the temperature as a function of time. So it implies that if the value of t is given, then the function will give the value of the temperature at the time t, okay. These are the differential equation, okay. For acceleration of a car, for population increase, okay. Yearly, monthly also there is an increase in population, okay. In networks, okay, in chemical change, locus of a football. So these are the behaviors, okay. These behaviors may be captured by differential equations. It is changing with respect to time, okay. That is the differential equation. See here the formula, okay. What is the formula, okay. Consider a function f of x, okay. Consider a function f of x, okay. See in your book page number 62, example, okay. That example, consider a function f of x is equal to x square. Sometimes it is also f of x is represented as y, okay. So y equal to x square. So here y is called the dependent variable, x is called the independent variable, okay. How? Let me tell you. So y equal to 2 nu vechikoyen, y equal to that, okay. The first equation f of x is equal to x square. Appo x is equal to 2 potena, what will be the answer? That is 4. X is equal to 3 na, answer is 9, okay. Like that, y equal to x square. So y is a dependent variable, but x is a independent variable. So if x is changes, y also change. 2 potona, f of x is equal to 2 na, f of x is equal to x square. So 2, that is 4. Do you understood? So hence y is called the dependent variable and x is called the independent variable, okay. Have you understood? So once a physical quantity is represented by a function, one can study the variation of a function over time or the over dependent variable on which the quantity depends. So calculus is the branch of mathematics used to analyze the change of any quantity. Calculus is the branch of mathematics that is used to analyze the change of any quantity. It's a branch of mathematics, analyze the change of quantity. Okay. So, the derivative of a function describes the slope of a curve at any point. That is, the slope of the line is a tangent to the curve. See that's the picture. Okay. In the see in the slide, the top, there is a straight line and there is a slope. So, slope of a line is a tangent to a curve. So, for finding the function of that slope, we can use the derivative. Okay. The slope can be computed using the concept of limit. Okay. Concept of limit. Okay. So, here m equal to del f of x by del x. Okay, equal to f of x plus h minus f of x by x plus h minus x. So, it becomes f of x plus h minus f of x by h. So, the final definition f dash of a. So, there is a value, we have to differentiate it. So, the formula is applying the limit, initial limit to final limit, that is h to 0, and the formula f of a plus h minus f of a by h. Okay. Do you understood? This is the formulae. Okay. You have to derive the problems. Example 2.18. Okay. By this formula. Okay. That's all. This is the differential equation. Now, integral calculus. Integral calculus. What is integration? What is integration? Integration is the inverse process of differentiation. Okay. It is the inverse process. Inverse process of differentiation. Okay. Instead of differentiating a function, we are given the derivative of a function and asked to find a primitive. Okay. That is the original function. Okay. Integration வந்து differentiation ஓட inverse process. Okay. Do you understood? Now, see the example, you will understand it clearly. Okay. See, consider the examples d sin x by dx. Okay. You are asked to integrate sin x. The value is cos x. Okay. So, you are asked to integrate ex, e power x. The value is e power x. You are asked to integrate x cube by 3. X cube by 3. So, that is x square. So, if x square is there, okay, see x square integrate பண்ண சொல்றாங்க. So, x power n equal to x power n plus 1 by n plus 1. இப்போ x square நீங்கள் differentiate பண்ணுங்க. ஒரு நோட் எடுத்துக்கோங்க. x square integrate பண்ணுங்க. Sorry, x square integrate பண்ணுங்க. x square into dx. So, x power n plus 1 by n plus 1. That is x cube by 3. Okay. So, அந்த x cube by 3 தான் ஆன்சர் வருதா, அந்த வேல்யூவை நீ என்ன செய்கிற, ஆப்போசிட் பண்ணுறேன்னா எக்ஸ் ஸ்கொயர் வரும். எக்ஸ் ஸ்கொயரை நீ இன்டகிரேட் பண்ணனா எக்ஸ் கியூப் பை 3 வரும். எக்ஸ் கியூப் பை 3 நீ டிஃப்ரென்ஷியேட் பண்ணனா எக்ஸ் ஸ்கொயர் வந்துடும். யூ அண்டர்ஸ்டுட்? எக்ஸ் ஸ்கொயருங்கிற வேல்யூவை நீங்கள் இன்டகிரேட் பண்ணிங்கன்னா உங்களுக்கு எக்ஸ் கியூப் பை 3 வருது. இப்போ எக்ஸ் கியூப் பை 3 நீங்கள் டிஃப்ரென்ஷியேட் பண்ணிங்கன்னா எக்ஸ் ஸ்கொயர் வந்துடும். யூ அண்டர்ஸ்டுட்? So, here, okay, from this example, the function cos x is derived function of sin x. Cos x is the derived function of sin x. We say that sin x is an antiderivative of cos x. Sin x is an antiderivative of cos x. So, in example 2 and 3, x cube by 3 and ex, the antiderivatives of x square and ex. Okay, you understood it? Now, what is average velocity? What is average velocity? Okay. What is average velocity? It is a vector quantity. It determines both direction and magnitude. Direction and magnitude. It is a ratio of displacement vector to corresponding time interval. It is defined as a ratio of displacement vector to the corresponding time interval. Okay. See here, there is a car. It has a displacement 5 meter, and to the right in the direction is given to the right, okay, and that is Time is 1.2 second. 1.2 second. Okay. Now the average velocity of the car is defined as a change in position during the time interval. So in the time interval குள்ள எவ்வளோ position change ஆயிருக்கு. So it is an average velocity because does not take into account speeding up and slowing down. It is an average velocity. It is an average velocity because does not take into account speeding up and slowing down. So எவ்வளோ ஸ்பீட் ஆகுது எவ்வளோ ஸ்லோ ஆகுதுங்கிறத கணக்கில் வராது. ஓகே, ஒன்லி இவ்வளோ டைமில் எவ்வளோ எவ்வளோ பொசிஷன் சேஞ்ச் ஆகிருக்கு. Do you understood? This much time, how many position, what is the change in position happens here. So that change, change is delta. Change is delta. Okay, delta ஏன் போடுறோம்? Delta equal to initial minus final. Delta is equal to initial minus final. So there is a change. அப்படிதானே? So for determining a change we have to put delta. Okay, see here V average. So average velocity. Average velocity is denoted as V average. Velocity is always V vector. So average, so we have written V average. So that is meter per second. The displacement is delta D. Displacement is delta D. Displacement is delta D. Okay, and the time is, yes, time, delta T, time seconds. Okay, time second. So that average velocity equal to delta D by T. So change in displacement by change in time. Okay, average velocity is a vector quantity, so it determines the magnitude and direction. Value also coming, and the arrow indicates that right direction. Okay, so the average velocity equal to change in displacement by change in time. So displacement by time. Okay, that is the average velocity. Now what is average speed? What is average speed? Average speed is defined as the ratio of total path travelled by the particle in a time interval. So that is the ratio. Okay, total path, that is the length of the total path and by total time. That's all. Total distance travelled divided by total time. That is the average speed. Okay, by using the formula you derive the problems. Okay, so the average speed is the total distance an object travels. Okay, ஒரு ஆப்ஜெக்ட் இருக்கு, அது travel பண்ணுது. Okay, the distance traveled by the object, it is divided by the total time the object has elapsed. So the overall speed of an object during the entire course of a trip. So the overall object, so the overall speed means an object during entire course of a trip. So instantaneous speed means speed of an object at a specific time. What is overall speed? It is a entire course, entire trip, overall speed of an object during the entire course of a trip. Instantaneous speed means at a specific time. So the formula for calculating average speed is total distance by total time. Okay. Now what is instantaneous velocity? Instantaneous velocity. So instantaneous velocity is a velocity at one moment of time. Is a velocity at one moment of time. So a car speedometer gives instantaneous speed. Car speedometer. Have you seen the car speedometer? In your car, that's a speedometer. Okay, that gives a instantaneous speed. What is instantaneous speed? Speed for a specific time. Okay, so the velocity at one moment of time is the instantaneous velocity. So to find this, to need to find the car's displacement in a very short interval of time. So to minimize the speed variation, we are mathematically writing V equal to limit, okay, delta T to 0. So that is the change in time up to 0. Okay, so del x is the displacement by delta T is the displacement of time. So we are writing dx by dt. So dx and dt is the change of distance by change of time. That is the instantaneous velocity. Okay, so this limit just means taking a succession of shorter and shorter time intervals at a moment of time. That is the limit. Okay, now what is a momentum? You have already studied in your first unit. Momentum is a quantity defined as a product of mass and velocity. Product of mass and velocity. So P equal to m into V. Okay, linear momentum or simply momentum of a particle is defined as a product of mass with the velocity. So it is a vector quantity because the direction is also the direction and moment magnitude is equal to the product of mass and speed of the vehicle. Okay, have you understood, children? For example, okay, consider a butterfly and a stone. Okay, consider a butterfly and a stone, both moving towards you with the same velocity. Okay, உங்களை நோக்கி ஒரு பட்டாம்பூச்சி பறந்து வருது, அப்புறம் ஒரு கல் உங்களை நோக்கி வருது. எப்படி யாராவது எறிகிறாங்க, ஸோ ஒரு கல் உங்களை நோக்கி வருது. Both of them moving towards you, okay, with the same velocity. Okay, butterfly velocity also 5 meter per second and stone velocity also 5 meter per second. So if both hit your body, the effects will not be same, isn't it? The effects only depend upon the velocity but also on the mass. Okay, so momentum equal to momentum அப்படினாலே ஏதாவது ஒரு ஆப்ஜெக்ட்ல ஹிட் ஆச்சுன்னா அதோட எஃபெக்ட் என்னங்கிறத கண்டுபிடிக்கிறதுக்கு தான் மொமெண்டம் யூஸ் பண்ணுறோம். தேர் இஸ் அ கார். ஓகே, ஒரு கார் வந்து ஒரு செவர் இருக்குன்னு வச்சுக்கோங்களேன், இந்த வால். ஓகே, இந்த கார் இஸ் ஹிட்டிங் த வால் வித் ஹை ஸ்பீடு. ஸோ அந்த இடத்துல அந்த பாடியோட மாஸ், அந்த காரோட மாஸ் வந்து 500ன்னு வச்சுக்கோங்களேன். காரோட மாஸும் வெலாசிட்டியும் எவ்வளோ ஸ்பீடில் அது வந்திருக்கு, எவ்வளோ ஸ்பீடில் வந்திருக்கு, அந்த பாடியோட மாஸ் என்ன, அதை பொறுத்து தான் அதோட எஃபெக்ட் இருக்கும். ஒரு பெரிய லாரி வருது, அதுக்கு 1000 வச்சுக்கோமே, அதோட வெலாசிட்டி சேமாக இருக்கலாம், பட் அதோட மாஸை பொறுத்து தான் அங்கே மொமெண்ட் நடக்கும். மொமெண்ட் மீன்ஸ் த எஃபெக்ட் டியூரிங் ஆக்சிடெண்ட். ஓகே, ஒரு ஹிட்டிங் நடக்குது, தட் இஸ் த மொமெண்டம். ஓகே, see, I told a butterfly and a stone, both are moving towards you in a 5 meter per second. Both hit you, okay, both hit you, but both velocity is same. பட்டர்ஃப்ளை உங்கள் மேலே வந்து இடிக்கிறது வலிக்குமா, ஸ்டோன் உங்கள் மேலே வந்து இடிக்கிறது வலிக்குமா? Absolutely, stone only, because the stone has a greater mass. Okay, stone has a greater mass that is compared to the butterfly. Stone has a greater mass which is compared to the butterfly. The momentum of the stone is greater than the momentum of the butterfly. So it is the momentum which plays a major role in explaining the state of a motion. Okay, state of a motion. So the unit of momentum is kilogram meter per second. Mass ku kilogram and velocity ku meter per second. So kilogram meter per second is the unit of momentum. Now motion in one dimension. Okay, motion in one dimension. Okay, if a particle moves in one dimension for example, that is a car is moving in a x direction. Okay, then the average velocity is del x by del t. Del x means the distance, del t means change in time. So the average velocity is a vector quantity, but in one dimension we have only two directions, positive and negative direction. It may be in positive direction or it may be in negative direction. So we can use positive and negative signs to denote the directions. Okay, dx by dt, that is the velocity. So velocity equal to displacement by time. It's a formula you already studied in your first unit. Okay, velocity equal to displacement by time. So change in displacement by change in velocity is average velocity. So a movement along a straight line. Okay, movement along a straight line, a description of motion that relates to the position and time. So we must be able to answer the question where and when the object is positioned to describe its motion. See in the picture, a car has moved from a point A to point B in a specific time period. Okay, motion is in one direction. Point A la irundhu point B ku car reach aayirukku. So the distance traveled, okay, the change in the distance and the time, change in the time. So that can be calculated by the average velocity. Now the relative velocity in one and two dimensional motion. Relative velocity in one and two dimensional motion. Okay, so consider two objects A and B. Okay, rendu object irukku, object A and object B. Okay, rendu verume moving with different velocity. Okay, moving with different velocity but respect to each other. Okay, with respect to each other. Okay, what happens, A with respect to another object B is called relative velocity. Okay, A va poruthu B. Okay, respect means relative அப்படினாலே ரெண்டு ஒரு ஏயும் இருக்கும் பியும் இருக்கும், அது ரெண்டுக்குமே இருக்கக்கூடிய ஒரு ஒரு ரிலேஷன். ஓகே, அதுதான் ரிலேட்டிவ் வெலாசிட்டி. ஸோ when two objects moving in different velocity, then the velocity of one object with respect to another object is called relative velocity of a object A with respect to B. So consider two objects A and B moving with uniform velocity VA and VB. Okay, along the same straight track in the same direction. Okay, now the relative velocity of a object A okay, two objects straight line travel ஆகுது. ஸோ இப்போ ரிலேட்டிவ் வெலாசிட்டி கண்டுபிடிக்க சொல்லியிருக்காங்க. ஆப்ஜெக்ட் ஏ பார்த்தோம் அப்படின்னா, see in your book page number 70, case 1. okay, case 1, two objects moving in the direction A and B. okay, see, first you have to find the relative velocity of object A. So V vector AB, position vector. okay, so VB equal to VA minus VB. Second one VBA. So VBA means V vector B minus V vector A. So these two objects are moving in the same direction. Two objects are moving in the same direction. The magnitude of relative velocity of one object with respect to another is equal to the difference in magnitude of two velocities. Difference in magnitude of two velocities. Okay. Okay. For example, I will tell you, see the example. Okay. Two cars A and B are moving with the uniform velocities. Uniform velocity with respect to the ground along parallel tracks and in the same direction. Velocity of A is 35 km per hour and it is east. Okay, and for B 40 km per hour, it is also in the east. What is the relative velocity? Okay, you apply the formula VBA equal to V vector minus VA vector. So VBA is the difference between 40 minus 35, that is 5 km, and same again also VA minus VB. Here VB minus VA, 40 minus 35, that is 5 km. Again VAB means VA minus VB, so that is minus 5. Isn't it? 35 minus 40 means minus 5 km. So to a passenger in a car, as the car B will appear to moving in the east with the velocity 5 km, but passenger in a train moving in the westward. So the direction is changed. Okay, the direction is changed. So consider another object, object A and object B moving with the uniform velocities VA and VB along the same straight track but opposite direction. See the slide, VA vector and VB vector, same velocity but in opposite direction. So the relative velocity of object A with respect to B is written as VAB equal to VA vector minus minus of VB vector equal to VA vector plus VB vector. Understand? VA vector plus VB vector. For another minus of VA plus VB vector. Okay, that is the case 2. Okay, in case 3 there is theta included. Okay, means there is a rotation. So rotation vandutnale anga theta value vandrum. So third one, two velocities VA vector and VB vector, there is an angle between their directions because it is rotating in a circular motion. So the velocity will be what? VR minus Vm. So root of VR square plus Vm square. The theta value tan inverse of Vm by VR. So these three cases are in relative velocity. Okay, so you have to apply it in problems. Okay, this formulas only you study well. Okay, you study the formula for case 1, case 2, case 3. Study the three formulas which will be useful for you for solving the problems. Side by side you solve the problems. Okay, make a problem note. Okay, and you do the problems side by side. Okay, see here for angle. Okay, third case, consider velocity VA vector and VB vector at an angle between their directions. The relative velocity VAB equal to VA vector minus VB vector. The magnitude and direction is given. See, okay, VAB equal to, it's like the triangular law of addition. Okay, in previous class I had taught you, know, that triangular law of addition, the same formula for finding the magnitude and direction. Okay, VA square plus VB square minus 2VA VB cos theta, and for finding direction tan beta equal to VB sin theta by VA minus VB cos theta. Okay, this is equal to a triangular law of addition. Okay, this is the case 3. Substitute the values and find the direction for case 3 problems. Okay, now what is accelerated motion? What is accelerated motion? Accelerated motion is a motion with changing velocity. Okay, what is acceleration? Acceleration is equal to change in velocity by time taken. It is the rate of change of velocity. rate of change, rate அப்படினாலே time கீழே இருக்குன்னு அர்த்தம். Okay, rate of change of velocity is acceleration with time. So change in velocity by time taken, acceleration A equal to delta V by T, delta V by T. So A equal to V minus V naught by T, V minus V naught by T. Its acceleration is measured in meter per second square, acceleration is measured in meter per second square. So an object will have an acceleration if the magnitude of velocity changes, the magnitude of velocity changes, the direction of motion changes, that is the acceleration. An object will have an acceleration if the magnitude of velocity changes, the direction of motion changes, that is the acceleration of motion. Now acceleration measures the rate of change of velocity. Acceleration measures the rate of change of velocity. Okay, the average acceleration is delta V by delta T. If an object changes its velocity from V1 to V2 in a time interval T2 to T1, புரியுதா, இனிஷியல் வெலாசிட்டி V1 இருக்குது, ஃபைனலில் V2 இருக்குது. ஓகே, see in your slide, Vf தான் ஃபைனல். ஓகே, Vi தான் இனிஷியல். ஸோ இனிஷியல் டு ஃபைனல், Vf த ஃபைனல் வெலாசிட்டி, Vi த இனிஷியல் வெலாசிட்டி, டைம் ஆல்சோ Ti இனிஷியல் டைம் அண்ட் ஃபைனல் டைம். ஸோ அதை எப்படி எழுதுறாங்க, del V by delta T. ஸோ சேஞ்ச் இன் வெலாசிட்டி by சேஞ்ச் இன் டைம், that is the average acceleration. That is the average acceleration. It is a vector quantity. It is a vector quantity. Okay, determines both the magnitude and direction. Okay. Now instantaneous acceleration. What is instantaneous? Instantaneous means specific time interval, ஒரு குறிப்பிட்ட பீரியடுக்கு. Okay, that is the instantaneous word. Acceleration is same. Okay, instantaneous, the average acceleration will give the change in velocity only over the entire time interval. It will not give the value of acceleration at any instant time. Instantaneous acceleration of a particle at a time t is given by the ratio of change in velocity over delta t, change in velocity over delta t. So acceleration A equal to delta V by delta t, dV by dt, dV by dt, delta V by delta t. Okay, the instantaneous acceleration is the average acceleration in the limit. Limit means or a specific time interval. It is very short period. So for calculating the acceleration for a short period, okay, for during travel, okay, during travel this kilometer to this kilometer, what is the acceleration? So for a certain time period, what we have to calculate, instantaneous calculation, instantaneous acceleration. Okay, right. Now projectile motion. What is projectile motion? Okay, what is projectile motion? When an object is thrown in the air with some initial velocity. Object is thrown in the air with some initial velocity. Okay, not upwards. Okay, it's and then allowed to move under the action of gravity alone. That object is called projectile. So the path of the particle in projectile is called trajectory. Okay, see here, projectile motion refers to the motion of an object thrown, okay, projected into the air at an angle. Okay, here is a boy, okay, he is standing on the rock, isn't it? Yeah, in a high place. Okay, he is throwing a ball. It is going down due to what? He is throwing down only, no? It is going down. That is due to gravitational force. Another boy is throwing the ball. It is going to a certain height and again it is coming down. It cannot go high because gravity, okay, at the maximum gravity will be 0, no? So it will not go high, it will come down. See another boy, he is making an angle, okay, at a certain distance. Okay, if we make an angle, then the distance will be different. So the motion of a projectile is determined only by the initial velocity. எவ்வளோ ஃபோர்ஸ் நீ கொடுக்க, எவ்வளோ இனிஷியல் ஃபோர்ஸ் கொடுத்து நீ ஒரு பாலை தூக்கி போடுற, ஓகே, உன்னோட எய்ம் என்ன, நீ எவ்வளோ ஃபோர்ஸ் கொடுக்க, தட் இனிஷியல் வெலாசிட்டி யூ ஆர் கிவிங், அண்ட் த கிராவிடேஷனல் ஃபோர்ஸ் ஆஃப் எர்த், திஸ் டூ ரியாக்ட் இன் ப்ரொஜெக்டைல், தட் இஸ் கால்ட் ப்ரொஜெக்டைல் மோஷன். ஃபார் எக்ஸாம்பிள், an object dropped from window of a moving train. Okay, in a train you are sitting on the corner seat. Okay, in the corner seat you are dropping an object from the window of the train. What happens? What happens? That is a projectile motion. Okay, the object will move down, okay. It will go to a certain distance and come down to the earth. That is called the projectile motion. A bullet fired from a rifle, okay. A ball thrown in any direction, okay. A shot put, okay. Have you played shot put, javelin throw? Yes. Yes. So, javelin throw, shot put also, we are giving a initial velocity and pushing that shot put, okay. It goes to a certain distance, but it comes to earth. Does it go upwards? No, comes down only due to the gravitational force. A jet of water issuing from a hole near the bottom of a water tank is also example. So, it is found that a projectile moves under a combined effect of two velocities, that is uniform velocity increasing or decreasing, okay, uniform velocity in horizontal direction. There are two types of projectile motion: horizontal projectile motion, angular projectile motion, okay. Horizontal projectile, angular projectile. See here, projectile in horizontal projection, horizontal projection. So, to study the motion of a projectile, we have to assume that air resistance is neglected. Air resistance is neglected. So, the acceleration due to gravity is constant in magnitude and direction at all the points of the motion of the projectile. The effect due to rotation of earth and curvature of earth is negligible. Okay. Consider a projectile. Consider a projectile, a ball, okay. A ball thrown horizontally with an initial velocity u from the top of a tower of height h. Okay. As the ball moves, okay, it uniform velocity u. See the picture. See the picture. Okay. There is a ball. Okay. It is in the the ball. Okay. That is a round one. That ball. Okay. That ball is thrown. Okay. It covers a horizontal distance due to uniform horizontal velocity and a vertical downward distance because of constant acceleration due to gravity g. Constant acceleration due to gravity g. So, the combined effect of the ball moves along the path OPA. OPA. See the O, point O, PA. The ball moves in the direction of OPA. That is due to gravity g. Okay, gravity g. The motion is in a two-dimensional plane. Motion in a two-dimensional plane. Okay, this is the motion along a horizontal direction. Motion along a horizontal direction. Okay, okay. I will tell you another example in a cricket game. Okay, in a cricket game. Okay, your favorite. Who is a favorite cricketer? Dhoni. Okay, okay. We take Dhoni. Okay. That cricketer Dhoni strikes a ball with a speed, okay, 30 meter per second, okay, at an angle, okay, at an angle. What happens? What happens? The motion is horizontal, okay, the motion is horizontal. The ball moves up to a certain height. Ball moves to up at a certain height, okay, certain height, and comes down, isn't it? It comes down suddenly. ஒரு ஹைட்டுக்கு போயிட்டு நல்லா போயிட்டு அப்புறம் கீழே வந்துடும், isn't it? Have you noticed it? That is projectile motion. That is due to projectile motion. Okay, children, have you understood? Now, time of flight. Okay, what is time of flight? The total time, okay, the total time taken for the projectile. Okay, projectile start from the initial to final. Okay, during projectile, the initial to final taking vertical downward motion, okay, from 0 to c. See in the picture, from the starting 0 initial point to the end point c. The time during that projectile is known as time of flight. So, here is the equation given, okay, y naught is taken as 0, y is taken as h, okay, vy equal to 0, ay equal to g, t equal to t, okay. By assuming the values, we are getting time of flight t equal to root of 2h by g. You have to remember the formula t equal to root of 2h by g. That's all, okay. Time of flight formula is root of 2h by g. Okay, children. Now, horizontal range of projectile. Horizontal range of projectile. It is the horizontal distance, okay, traveled by the projectile during the entire motion, okay. From the starting point to end point, okay, the ball is starting from the point, that red dot, okay, from the point to the end point with an angle, okay, with an angle, okay. The total distance r, see this total distance r from the initial to final, the total distance is called horizontal range. That is called horizontal range, okay. It is the horizontal distance travelled by the projectile during the entire motion. The overall height is called h, okay, that is height, and the total distance is horizontal range. Now what is angular displacement? Angular displacement, okay, consider a particle revolving around a point in a circle of radius, okay, in a circle of radius, okay. See, in a circle of radius are given a particle revolving around a point, okay. The angle described by the particle about the axis of rotation in a given time, ஒரு குறிப்பிட்ட டைம்ல குறிப்பிட்ட radius, okay, angle described by a particle, certain angle is given. The axis of rotation in a given time is called angular displacement. So, the unit of angular displacement is called radian. Unit of angular displacement is called radian. Okay. So, theta equal to s by r. S is the length of the arc and r is the radius. So, the length, see the picture, the length of the arc is s. Yes, okay, from A to B, taking a small area, that is the length of the arc, that is s, okay, and the distance is r. So, theta equal to s by r. Theta is the angular displacement. Theta is the angular displacement. So, in a circle, move in a circle from A to B. Circle A to B, radius r with an angle theta, the length of the arc is s, okay, length of the arc is s. This is the angular displacement. Circular motion. A particle P travels in a circular path, okay. Particle P travels in a circular path, okay. What happens? It performs a circular motion, okay. If a particle P travels in a circular path, see the picture, particle P, okay, that red dot, it travels in a circular path. It performs a circular motion about O. O is the origin with a radius r, okay. The P travels in a constant speed. The circular motion is a uniform, okay. That is a uniform circular motion. Okay, children, that's all, okay. Your unit 2 is completed, okay, and I will give you some homeworks and assignment, okay. The derivations, okay, the derivations in this lesson you have to go through it, okay. Do it by yourself, okay. I have also taught you the derivations, okay. Do the problems, okay, and today you have to write 10 one words, okay. 10 one words from the chapter 2, page number 60, page number 62, page number 95, okay. Page number 62, page number 95, you have to write any 10 one words, okay. Further, you have to write 15 short answer questions, okay. Take your book, page number 99, okay, page number 99, okay. One words is a homework. Write the one words in your homework note, okay. The short answers, okay. The derivations you have to write in a classwork, and also I have given assignment also. Today there is no assignment, okay, only classwork and homework, okay. Write the 10 one words in your homework and write the 15 short answers in your classwork note, okay. Page number 99, short answer questions, okay. Short answer questions, there are 1 to 15, okay. First one, explain what is mean by Cartesian coordinate system, okay. You search in your book, okay. Define scalar. Are you having guide? Some children may have guide, okay. You go through it, otherwise inside your book all the answers are there, okay. Define a vector quantity, give example, okay. Short note on scalar products, okay, vector product, okay. Displacement, distance, velocity, speed, acceleration, what is radian, okay, everything I have taught you, okay. So, go through it, okay, go through your book, or some children may have guide, okay. Okay, go through it and write it in your classwork, study and write, okay. Study and write, okay. All the questions you have to study and write the 10 one words by yourself, okay children. This is your homework. Have a nice day. Thank you.